In this lesson, we're going to evaluate the integral of the square root of e to the power x minus 1 with respect to x using substitution methods. Our goal is to solve the integral of the square root of e to the power x minus 1, all with respect to x. The first step in using substitution methods is to select a substitution that simplifies the integral. In this problem, let's try substituting u equals e to the power x minus 1. The reason why we choose the substitution is that the square root term can be simplified directly to the square root of u. We then need to determine dx in terms of do, so we take the derivative. Do equals e to the power x dx. Next, we'll solve for dx. Since u equals e to the power x minus 1, we find e to the power x by solving for e to the power x to be equal to u plus 1. Now, let's isolate dx in terms of do. Dx equals do divided by e to the power x, which we just found as u plus 1. Substituting back into the original integral, we obtain the integral with respect to u is the integral of the square root of u over u plus 1, all with respect to u. The integral of the square root of u over u plus 1 involves partial fraction decomposition to separate this into more manageable integrals. However, it is valuable to note the methodical steps like identifying substitution, rewriting the integral, and the recognition of familiar patterns such as derivatives. Let's conclude our explanation by rewriting our final expression. Through this process, by substituting and transforming the integral, we've managed the complexity toward solution. In practice, a numerical or symbolic computation tool might be used for intricate functions that arise from substitution.